Welcome back. It's Matt Roush.
And Mike Brennan.
And we're back once again with our weekly visit from our own resident infectious disease expert, the man, the legend, the co-creator of over a dozen vaccines. I think you were involved in the creation of, right? Something like that?
Half a dozen, but
half a dozen. Okay,
so that's 3 million people a year.
Okay, so that's Fred Brown, and he's back to give us the latest updates on the coronavirus pandemic and the vaccines that are apparently quite effective at reducing the severity of the disease.
One of the things we didn't get to last week, because Fred has so much material. By the way, how did your 74 slides in 45 minutes go with those other folks? Did that work out for you, or?
I cut it down to 68 minutes, 68 slides, and yes, it was okay. They had a couple of questions at the end, but we went through it all. That was to the Michigan Economic Forum, and who does all the economics for Michigan, and we had to skip through a lot of the economic sections, which probably was just as well because they probably know a lot more about economics than I do. But we went through it all, and.
I was going to ask if you maybe set up a stopwatch, and it just after every 40 seconds or so, it would just go ding, and then you'd have to go to the next slide.
Automatic.
Yeah.
Oh my God.
Well, one of the things that we didn't get to that we wanted to get to was how safe are these vaccines? Because I try to keep up with my reading on this. Obviously, you have much better information than I. But I'm seeing side effects with some of these and different issues coming up. But what's your take on
the occasional strong allergic reaction seems to be happening, which I guess isn't that unusual, but
that's right. Yeah. So the safety actually is starting to look slightly better than the flu vaccine. Dr. Fauci came out today and said that actually, if you're taking, the flu vaccine, which we have a lot of experience in, seems to be even, the new mRNA vaccines are even safer than that. I don't want to say that yet because we still have some longer term issues to go through. But if you want, I can kind of talk. I have a couple slides I can show you if you're interested, or we can just talk it through. So
no, as long as it's not like 58 or something, we'll be okay.
So on the safety, remember we talked about these four big factors, and we went through efficaciousness last time, and it's 95% efficacious, which is fabulous. But we don't know whether it actually reduces the transmission yet or not, and that's a big factor because we could just be reducing symptoms. If that happens, what happens is the COVID virus stays in the environment because we can't reduce its transmission. It finds its hosts. Every once in a while, it'll find someone who isn't vaccinated or is super susceptible at risk and will kill them, as it does today. But for most people who have the vaccine, the symptoms won't be that bad. The issue becomes if you've got an awful lot of the stuff in the environment, then you're constantly sick. You lose your productivity, and if we don't know whether or not even low symptoms can cause bad long haul effects, which we know they can, then you can still have a lot of lingering issues, cardiovascular issues, central nervous system issues, fatigue issues, and so on that we've seen in long haul effects of people even with low symptoms. For example, I told you about my cousin who, had it and didn't even know he had it, came back and now has Guillain-Barré syndrome, GBS, and had to relearn to walk, had to relearn to talk, even though the symptoms were completely asymptomatic. It turns out now he has long-term GBS, and he's going to have to get infusions every month. If that happens to a large number of people who get the disease but aren't very symptomologic, even with a vaccine, then we've got problems. But we're still finding that out. In 3 months, we should know whether or not it's effective in reducing the transmission. We have evidence that we think that it can reduce transmission between 50 and 80%. But I'm sorry, 48 and 62% is what Moderna is saying right now. That's very, it's not really what one of their endpoints are. They've got to redo a lot of the work, but we think it may be in that range, which would be great, because we reduce transmission, that actually kills off the virus. Now, as far as safety goes, you can see in the checks, this is what we've given the current virus credit for. Let me put it on slideshow so you guys can see it more easily. And the check marks indicate that, in my opinion, after looking at all of the clinical results, The current virus clinical trials have demonstrated that it has a low rate of serious adverse events. Serious adverse events are ones that actually affect your fundamental physiology and organ systems.
Mm.
And we see that happening every once in a while. We saw, for example, that there's Bell's palsy. And we saw that in the placebo group, one person got Bell's palsy anyway. We saw that in the active group, 4 at Pfizer and 4 Moderna, or a total of 8 people got it. And that was in about 100,000. I'm sorry. We think it's in the kind of range of about 5 per 10,000 instead of 1 per 10,000. So, that's still not statistically significant. It still could have happened by chance that these people just happened to be, put in the different groups and got Bell's palsy just in the general population, because it does actually hit at about 8 in 10,000 rate naturally, between 1.5 and 8, depending on the situation. Naturally, it is an autoimmune disease, so it could have been a real safety event. We're not sure yet, but that's sort of the rate we're talking about. For example, and as far as allergic events that you talked about, 6 people who've taken the Moderna vaccine out of about 1 million total have had a serious adverse event that required epinephrine. So 6 in 1 million isn't too bad. That's and so far no one has died because they've had the epinephrine pen. They knew they had the issue, the situation. They took Benadryl in advance, they took epinephrine afterwards, and they walked away fine. But they had a scary event. Obviously, you start to get anaphylaxis, and yeah, that's scary. But they knew what was going on, and there wasn't any surprise. So that's sort of where we are with the serious adverse events. We're talking at a rate of in the 1 in 10,000, 1 in 100,000 rate that we've seen so far on organ systems, which is considered very safe, because these could have happened. These are not statistically significant events. They could have happened anyway. Broad clinical trial inclusion. We had a very broad basic clinical trial inclusion. You saw 20 to 25% were people of color. We saw 10% were Black, about 25%, up to 25% were Latinx. We had Pacific Islanders involved. We had people of all age groups involved, above the age of 18, even over 85. And so we didn't restrict this trial at all, which means we had a very good broad population. And we also were what they call very balanced. That means that we didn't look for elderly white people with diabetes. It was kind of naturally spread across the population as you'd expect to find them. So that also is good. It was a fairly unbiased sample population. If anything, it was biased toward the more risk and more people of color than the actual population. We did have a couple of admissions you saw that were a little bit underrepresented. We haven't really checked the safety for a significant number of HIV, HPV, and other long-term chronic diseases. In spite of that, the CDC came out today and said that they believe, based on the data presented, that it is more risky for those people to get COVID than to take the vaccine, and therefore they are advising even immunocompromised patients, upon the advice of their doctor, to take the vaccine. Even people with long-term chronic conditions that weren't completely represented, but did have some representation in the trials, to be vaccinated. So we're starting to see, and they're providing funding for those people and providing prioritization for those people. So they'll be some of the first people vaccinated, which is interesting. It means that they've really looked at this carefully and decided that they think, and I agree with them, that the chances of catching COVID and the adverse events from having COVID are far outweighed by taking a vaccine that's, we don't have complete absolute security on in terms of long-term safety. And up in the upper left-hand corner, you can see that low thresholds and types of adverse events. We looked for them in the 1 in 10,000 rates. We're not finding them yet in the 1 in 1 million rates yet, but we will shortly after we start to roll this out. And we've got large numbers of subjects. The only issue we've got is, by nature of the vaccine, we only have about 5 months of data on any given patient. And most of the people are still kind of 2 to 3 months into their total vaccine after 2 doses. So that's the only sort of area, as we start to get more and more people vaccinated for a longer and longer period of time, that can possibly be a problem. And if you know, immunologically, it's hard to imagine an adverse event that comes through 6 months, 7 months, 10 months out. You know, most of these events happen within certainly the first 6 weeks. That, you know, at least in our experience, it would be rare that we have, extremely rare that we have an adverse event occurring, you know, a year later. You suddenly, if something happens that are you suddenly affected by the vaccine, that's doubtful that that would happen. It's possible, and all these trials are for a 2-year period, so we'll know that. But that's sort of where we are right now with the safety. The one thing about the clinical endpoints that I wanted to say yesterday, last time we talked, is there is a chance that we could have a 1-dose vaccine. That's not true for the over 55s. If you're over 55, you always want to take 2 doses of this thing. Because they're not sure about the durability, not sure, and the efficacy, when it drops to 80% instead of 100%, you still want to take 2 doses. And so let's take a look at the safety data. As I said, the 2 big issues about safety are its frequency and how fast it occurs. And so we have seen, we've gotten rid of the area of greatest risk, which is very frequent adverse events that are occurring very quickly after you take the vaccine. We're pretty sure that that isn't going to happen for most people. There may be a couple populations out there that have some challenges who are allergic, but we don't think we're going to see much more of this. We think we've tested enough. There is the most dangerous scenario we've got is kind of looking out for the next 4 months or so, and we have a serious adverse event, and I don't think that's likely to happen. That we're going to see populations, but we'll see. You know, we're going to start to stratify the populations more carefully, see a lot more very specialized populations, very special, perhaps Native American populations, and other populations that may have some host factors that make them, or recipient factors that make them more susceptible, or the virus, the vaccine less effective or more dangerous for some reason. But we don't think that's going to happen. The other big issue is we have to get to the 1 in a million plus issues where you've got very, very serious adverse events happening to very, very small populations. I don't think that's very likely either, but again, we're starting to close in on this range where even that whole red spot is going to be missing. So you can see that we're looking carefully at the risk of what they call antibody-dependent enhancement, or ADE. This means you start to select for a virus that is much more dangerous because you've had a partial vaccine or partially protected by a vaccine. And that happened, we believe, in the case of South Africa and the case of the UK, where somebody was on long-term medication that caused them to continually select for a more dangerous virus. And now we have a more dangerous virus, more dangerous virus in both those countries that are slightly different. The one in South Africa has 22 mutations, which is rare to have that many mutations, and the one in England has 15 mutations. They are slightly different strains, but that arose differently as a result, we think, of adverse selection due to medication that people were on. And we're going to start to see that. Hopefully we don't select for right now they're selecting for things that are reproducing better. But eventually we could start to select for things that perhaps are more deadly. And that's what we really want to make sure, that it's not more deadly and that it doesn't escape our vaccines. Because right now our vaccines are very, very precise, right? We've focused on a couple, literally 4 different proteins on the spike protein that, at various levels of each of these vaccines that we're out after, including the vector vaccines that are coming down the pike. If we change those proteins just enough in the virus, because we've selected for rapidly enough, we could suddenly have ourselves with ineffective vaccines. That's unlikely because the spike virus is the same thing that makes the spike virus super specific for the ACE2 receptor sites on the cells, which allows it to inject itself into our cells, is the same virus that we've got, we've created these the vaccines against. So it's going to be hard, but there's a narrow pathway that you could imagine when you have this in a billion people, you could start selecting for. So we are going to have to watch that and make sure, and luckily we've got the technology now with mRNA vaccines as well as vector vaccines, where if we have the new genetic sequence, and we're watching this pretty carefully in Europe at least, that we could then create a new vaccine, right? We see that takes about, now we're down to kind of a 10-month period where we'd be adversely affected for a few months, but we could get that vaccine on stream pretty quickly based on our regulatory knowledge right now. If the regulators are able to say, yes, the vector technology works, it's a new antigen that you've put into the vector. We'll test that with 1,000 patients, and you're ready to go with bridging studies. We could get to that point and very quickly respond. The problem is that the United States only looks at, we right now, Europe is actually doing genetic sequencing on about 10% of the samples that come in. That's a lot, right? And that's a lot of genetic sequences. We're doing it on 1/100th of a percent in the United States. So our systems are just not up to the standard that we should be, frankly, for watching this, given that we're injecting so many more people than Europe has right now in the space. So that has to get better. And I think ultimately WHO is going to start to recommend and require this. They've got a special operation in WHO that asks every country to start to look at how good they are detecting virus. And I think we're falling way short of that in the United States, and we're going to have to come back up to that standard just for our own. Even if we don't rejoin the WHO, we want to do it anyway to protect our citizens. So it's just a very minimal requirement. Right now, we're 84th in the world as far as our ability to do that compared to all the other countries. That's not that you don't want to be at 84. You want to be at number 1, 2, or 3. Trust me on this one. You don't want another pandemic to come through, and we're kind of in the 26th percentile overall. And that's a flunking grade on anyone's scale, even if you're pretty carefully on the curve. So we have to come up with standard there. The risk of late onset serious adverse events, SAE stands for serious adverse event. And so those are the ones that you really want to watch. The adverse events that we talk about right now are largely what they call reactogenicity. And we'll get into that in a second, but there's a difference between reactogenicity, which means that the virus is working and you're feeling an impact of that, and a real adverse event where the vaccine is actually attacking parts of your body that you don't want it to go to. And that, as I said, that's very rare. That serious adverse event is extremely rare. The excluded populations, some pregnant groups, some ethnic groups, under 16 certainly are a big factor. And I do worry a little bit about the children, on these it'll be very important to monitor if we can or cannot vaccinate kids. If we can vaccinate kids with a durable vaccine at the age, below the age of 2, for example, that would, and we have something that's actually reducing transmission, that would actually kill off the virus. If we can't, then we'll have a lot of transmission among the young back up to the old, and a lot of sickness will remain in the population. So that is the most significant population that we're not studying yet. And then, of course, the prior disease questions. We can't know every prior disease people have had. We don't know the combinations of diseases that could come together and suddenly make the vaccine a little more dangerous or less dangerous. Watch for that. We're going to get into that more and more as we vaccinate more and more. And then the real world impact. It turns out that, in a clinical setting, it's a lot easier to give a vaccine that's going to be effective than in the real world, where you've got cold chain issues that can significantly dampen the effect of a vaccine, the impact of a vaccine if it gets warm for too long a period of time, or you don't get your second dose, which happens a lot. Actually, almost about 50% of the people who require second, third, fourth, fifth doses don't get those second, third, fourth, fifth doses. That would be a big problem. And so there's some issues about safety we've got about that we'll return to about those things. Those are the critical unknowns. But overall, here's the reactogenicity profile, and you can see that if you take the vaccine, the best day of the week to take this vaccine is a Friday, and the reason for that is because the next day, Saturday, you won't be feeling great. Sunday, you'll be feeling pretty miserable. But by the time Monday comes around, you should be getting back to normal, and certainly by Tuesday, everything's going to be really, really good. This is what you'll feel. Generally, there will be some fever, not on day day one, but on day two, you'll have a little bit of fever. That's where the most biggest impact is. You probably want to take it. You may want to take a day off for that on day two. Fatigue will be high, headaches will be high, chills will be, you could have chills and muscle pain, joint pain. And the second time you take this, it will be worse than the first. And if you're younger than 55, it'll be worse than older than 55. So the second doses of people in the kind of in the younger kids who get less benefit from the vaccine are actually going to be the worst impacted. So the people who are getting the least benefit are going to be having the worst reactogenicity, unfortunately. So hopefully that won't change the fact that you want to take the vaccine and beyond the vaccine, but it could affect it. But the good news is us older guys don't feel it as badly. But us older guys actually do need two doses for sure, versus the younger people would maybe be able to get away without a second dose. We'll have to see, wait and see what Pfizer's trial says. So that's the general level of issue you're going to have. What's interesting is when you look at this level of issue versus what happened to the placebo group, right? The placebo group got water, saline. And the active group actually got the vaccine, 50-50. So 17,000 people on the Pfizer each got either a real dose or a saline dose. 15,000 people either got a real dose or a saline dose. That's what this was based on. And you can see that people who got the saline dose also didn't feel that great, which is important to recognize, right? So statistically, the things that you probably most feel are fever, chills, and muscle pain.
Oh boy.
Yeah, that's wild, isn't it? The placebo. This is why it's so important.
That, yeah.
And this is what we're so worried about when we lose the placebo group. Eventually, we're going to have to give the real vaccine to people who are on saline, right? I mean, you can't expect people to sign up for a clinical trial and then be restricted from having the real drug. So when that happens, what we're planning to do for Pfizer, what we're planning to do for Moderna is we're planning to tell the people, there are two possibilities. We may just say you need a second dose, and whoever didn't have the real thing will get the real thing, and whoever did have the real thing will get a saline. But that means that after that probably within about 4 months or so, we won't have any more placebo group to compare the guys who got the real vaccine to, and that actually reduces the power of this for long-term safety. But that's what we have to do just to be proper. Moderna's current trial says everybody gets the real Moderna vaccine immediately after this is approved. Pfizer says, no, we're going to, we'll do what they call a crossover trial, where you cross over, as I described, from placebo into real or from real into placebo for 2 more shots when they become eligible for the real vaccine. And that means that you'll be offset a little bit from the placebo group. You have an extra 4 months of history of having nothing, and then having a real vaccine, which would be helpful to understand efficacy better. But some of this long-term safety, because we don't have a placebo, is going to be impacted a little bit. But that's what we had to do in order to do these kind of trials.
Let me ask you, Fred, if you have a choice between the two, which would you take?
Right now, statistically, there is no difference. And the issues that are out there between the two are more about durability and will be more about scalability than about efficacy and safety. If I had a choice right now, because I'm a little bit older, I'd take the Pfizer vaccine, because there's a little bit more evidence that you have efficacy in the elderly populations with Pfizer. But again, it's not statistically significant. So but the most important factors are going to be durability, right? What's going to happen is when you go up to this chart, the most important things are what's happening down the bottom, right? Safety and efficacy seem like they're pretty good. But if we have efficacy that only is symptomologic, and we have very poor durability, you can imagine that that's going to be a real problem. Because what's going to happen is you're going to have to constantly see whether or not you're going to have to constantly kind of take serology tests to find out whether or not the vaccine is still durable or not. And that's a factor that's going to be awkward. And if it's not scalable, Pfizer's is much less scalable than Moderna. So out in the field, if we find out that we really can't keep this thing cold enough and the efficacy drops significantly in real life, then again, the Moderna vaccine would come up way ahead of the Pfizer vaccine. So there's a little bit where we're lacking information to make a final decision about which I would take personally, but I would definitely take one of them. And if it was offered to me, there's no doubt about it. This is just such a good vaccine compared to having no protection at all.
What are you hearing about the availability of these vaccines? I know there was some controversy last week about Pfizer saying they had, millions of doses sitting in warehouses and they hadn't been told where to ship them or when to ship them.
Yeah, we do.
So what are you hearing about that?
So yeah, I am working with OWS. We do have extra dosing, and that's because we haven't been told where to ship. So Pfizer ships directly. Pfizer gets their orders and they ship directly to the final injection sites. And states weren't up for that. They weren't up to tell Pfizer, ship to this hospital right now. They have sufficient capacity. And the hospitals weren't able to tell them, we've got enough minus 70 degrees Celsius capacity to take this on, or we have enough people signed up to do all those doses in the next 5 days, right? You got to do 1,000 doses within 5 days. That's a lot of shots if you don't have the refrigerator capacity. So they were worried that if they weren't get, they knew who was signed up, but they were worried that if they didn't get the actual order and the order entry system through the Tiberius system that CDC set up, that they would be wasting doses. The other thing we found about Pfizer is that they actually have 7 doses per vial if you do it right, rather than just 5. And so all of a sudden, people had a lot more than they anticipated. They were suddenly, you can imagine that's what, 20% extra you've got, 14, 15% extra you've got in every vial. And so they were, scrambling around trying to get people to vaccinate, that weren't signed up yet and hadn't signed off on the paperwork yet. So it was a little bit of a teething problem initially. The other big problem that we had, the real problem that General Perna had, and he took the blame for it, but he didn't have to, frankly. It was because the FDA requires a 2-day period in quarantine to make sure that the vials are properly, the vials don't have any bacteria growing in them and so on. So we've got there's a release period, and typically for many viruses that can be up to 6 months. So the fact that we got down to 2 days is remarkable, but they hadn't calculated that in, and we're producing this stuff at such a rate that a couple days means several million vials. So that period hadn't been calculated into the demand projections appropriately, or the supply availability projections. And so
let me ask you too, these refrigerated trucks that they're using for temporary morgues, I don't know much about them. Can they go to minus 70 degrees Celsius, those refrigerated trucks, or not?
No, they're not. They're typically at refrigeration rates. We don't even freeze the bodies.
Really?
Yeah.
Okay.
So right. So that's not, and they have to really precisely control. Every vial has a thermal indicator on it that would indicate whether you're on or off. And the problem is if you waste too much of this, the refrigerator trucks don't have enough precision in that. If you look at those refrigerators, the minus 70 refrigerators, they're only about the size of a pizza box, right? They're very narrow, very small, so they don't rise much. You don't have much temperature difference in that distance. Minus 70 is minus 70 degrees centigrade. It's almost minus 100 Fahrenheit. That you can't keep that much that much space that cold.
Yeah, I was gonna say that's like outer solar system cold. Right?
That's right. You're talking about Mars. Yeah, exactly. You're starting to get toward planet, or what do they call it? Europa, the Saturnian or the Jupiterian moons kind of levels of cold, I think. And not quite Neptune or Uranus, but close, apparently. So I'll just show you some of the data that came back in safety, and then because that's the most important. Here, you asked about adverse events, especially around allergy, and you can see what this is it's a fairly complicated Monte Carlo simulation that I've simplified a little bit, but it shows what happens if you've got a serious adverse event that hits between 1% and 10% of your population. That's an allergy, right? And that is on the left-hand side. And you can see that what happens is that you do get a big separation early on when people are surprised by an adverse event. But eventually those people start to move themselves out of the population, and you're able to absorb that population and address it differently. And the rest of the population then gets down to you can see the 1,200 dose with no vaccine to 375 with a vaccine that has an adverse event between 1 and 10% of the population unable to take it due to an allergy. We're well below 1%, right? We're 6 in a million. So we're well below that level. But even if we were at 1 to 10% for an allergy, you're not going to get that much of a negative impact. Where you get a really bad impact on a serious adverse event if you suddenly have a big population that has a high mortality, and that's on the right-hand side. And you can see that if you have a high mortality rate, and those people are excluded because they have consistent adverse events. So, for example, if all the diabetic patients couldn't take this, that's a big part of the population. And if 10% of those diabetic populations couldn't take the vaccine, you would see you would have a very low drop in the total death rate. Right? It's from 1,200 to 1,100 on that right-hand piece. Well, that's just with a single vaccine. If it's 1%, it's better. It's down to 485, but it still is not as good as if it's just an allergy that's sort of random, occurs, because the allergy occurs, versus if you've got something that's systematic in your population that really has a problem and could die. So that's the difference between a serious adverse event and an allergy. And the serious adverse events we have not seen, and I don't think they're going to show up, which is great. We have seen some allergies at a much lower level than this, and it doesn't really impact the vaccine rollout or the impact on achieving herd immunity much, which is great. So here's the ultimate question: do these adverse events cause death? And the answer is no. You can see that, in fact, there were more deaths in the placebo group than in the Pfizer drug, and Moderna, it was actually almost statistically significant lower in the people who took the vaccine versus the placebo. It may be that there's benefits to taking the vaccine generally that are causing a lower death rate, believe it or not. So it turns out that there are no serious adverse events that are going to increase death rate. You are going to read about people, my Uncle Joe, 3 days after he took this terrible vaccine, he had a massive heart attack. Well, what this says is statistically, the chance that Uncle Joe died of that heart attack because of the vaccine, and the chances that his time was up, sadly, that you can't distinguish between the two. That even though you'll hear anecdotes about a terrible thing that happened to someone who just after they took a vaccine, that happened due to chance, according to these data right here, which are statistically significant, not due to the vaccine. And so the risk benefit basically is great, right? It's for the proposed indication. It's effective. It's extremely safe. You can see, for half these people actually had the vaccine, half of them did not, and the overall efficacy was as high as we think it was. They are going to do some more clinical studies. They're going to take a look at boostability and durability. These will be really critical, right? How often do we have to take these stupid things, right? If it's once and done, or once what we prime them and then we boost them. If that's all we need for our lifetimes, that would be fabulous, and we will really eliminate the scourge completely. But if it's something we have to take every year, and people aren't very enthusiastic about it, then we're going to be fighting this for the rest of our lives.
Well, particularly if the day 2 and 3 are really not good, people will remember that, right? And not be really excited about going through that again, right?
That's exactly right. As interestingly as they get older, that day 2 effect, that for second dose and boostability dose won't be as bad, but they probably won't give it a chance.
Right.
But that's exactly it. Yeah, if you're boostable, chances are you're going to have a slightly bigger negative effect reactogenicity than if you aren't, because you've got some of those antibodies in you already. We want to do dose ranging studies, especially the dose ranging we talked about was can we get away with 1 dose in some populations? We're not terribly enthusiastic about this from the public side, because if it is really 95% effective, and with 2 doses, and it's only 80% with 1 dose. That believe it or not, that 15% is really, it's really, really important. And and that's because we're pretty tight on the herd immunity, and I'll show you that in a second. But the pharmaceutical industry doesn't want that because it halves their market, right? If you go from 2 doses to 1 dose and you're selling everything for $10 a piece, then all of a sudden your market goes in half. And so, it's still a $5 billion market instead of a $12 billion market, but it's smaller, So they're not really enthusiastic about doing this study either, frankly, unless it gets it out faster and gives them, more monopoly power. The use of pregnancy and pediatrics, the American Association of Pediatrics did come out and say we think that the overall pregnant women, upon the consultation of the doctor, should get the vaccine, but certainly not the young children yet. Use of immunocompromised, again, people are saying looks like from a risk-benefit analysis, better to take it than not take it, even if you are immunocompromised. We want to take a look, especially at stability, right? Because the poor people, it turns out that if you are searching for herd immunity, and suppose 70% of people are herd immune, and everyone around you is sick and has COVID. Well, that 70% herd immunity, the 30% who didn't take the vaccine, they're still super at risk, right? Because they're eventually going to get touched by somebody around the world somewhere with the virus and come down with a bad disease. So you want to make sure that stable second generation formulation gets out to rural populations, lesser developed countries, everywhere in the world. So that refrigerator stable second generation formulation for Pfizer especially is important. And you can see Pfizer wants to put this in the flu vaccine. These are multivalent vaccine opportunities. I'm actually an expert in that space, and that's a great idea. If we have to do this every year, you may as well get it all together.
Sure.
And so this is some of the things that they're going to be looking at now that they're on the market with the EUA. We don't have to have all these studies done in order to get the real final approval. What they call the BLA, this is the Biologicals License application. The BLA should come out probably in June, July timeframe for both these companies.
Let me ask also, I've been hearing that Johnson & Johnson's going to come out with one, or is coming out with one that's a 1-dose vaccine. Is that correct?
That's right. Yes, that's right. J&J has always been looking at the 1-dose option. They have actually, what they did is they realized, gosh, now that we've got real vaccines out there that are effective at 95%, we better get going. They originally had designed their trial with 60,000 patients. So they really wanted to look at a lot of different patients to be able to say with a lot of certainty that they were good for any population. And so they had a broader inclusion-exclusion criteria selection process. And since the EUA approvals of Pfizer and Moderna, they've reduced their size of study to 30,000. So they should be ready to conclude that study by mid-January and on the market, mid-January to mid-February, and on the market by kind of March 1st is what I'm projecting right now. AstraZeneca uses a slightly different vector and a slightly different piece of mRNA. And they are going to be approved in the UK, but they made those mistakes. So they have to go back for the US and demonstrate either a 90+% efficacy rate in the half dose plus the full dose boost, or to resolve themselves to be to just focus on the under 55 age group and have a vaccine that's about 70% effective. My guess is that I think the single dose will be less durable and it'll be less effective than the big dose, but it makes a big difference when you have a single dose in what happens to how fast you get to herd immunity. And I can show you that here, where you can see that with Pfizer and Moderna, this is how fast it's going to take us till at least October, kind of Halloween timeframes, to get to a point where we're getting pretty comfortable with most people around us. Now, some communities won't be inoculated appropriately, that we'll know that, have to wear our masks, but generally we think the inflection points around, if we only have Pfizer and Moderna, which have 2 doses. Moderna, for example, you're ready to go with Moderna. You have to take the first dose. 28 days later, you take the second dose. 14 days after that, that was their endpoint for efficacy. So you've got to wait 6 weeks after you've taken your first dose of the vaccine to truly be what they would consider protected. Now, you'll have some protection between that period of time, but we're not sure about how much. And so, we really can't count on that for what they call the herd immunity effect until 6 weeks later. So you can see how long, and for Pfizer, it's 1 month, right? You take one dose, 21 days later, you take a second dose, 7 days later after that. That was Pfizer's endpoint. And they found that, after that 1 month period, you were 95% effective. Moderna took a month and a half to find that 95% efficacy. So it takes a long time to march down that herd immunity curve. Now you've got J&J. Suppose J&J is 90% effective after just 7 days.
Whoa.
Right?
Yeah.
Well, look what happens to your curve. That's that. Your curve gets, but gosh, by August we could be all set versus having to wait until Halloween. So
well, plus you only have to go through the day 2 and 3 once, right?
Oh yeah, then you have to go.
Twice,
No second dose, which is a big factor, like we talked about. So yeah, so it turns out that single dose, now eventually it'll all level out, and over time, if you have to have a booster every month, every year for J&J, or every year with Pfizer, Moderna, you're not going to care much. But in the initial bouts of the fights that we're having against the virus, it turns out single dose is really important.
Okay, we've got about 3 minutes left.
Holy cow, that went fast, you guys. We haven't even talked about all the important things.
It always does, Fred.
Well, so this is the reason that 85% or 95% makes a big difference. And I'll just tell you quickly that basically, if we get 90% effectiveness, but we only half of us take it, we're not going to be herd immune. And we're going to have to keep wearing masks and everything else. So it turns out that when you're at 85% or 95%, it makes a big difference. That first or second dose question, so you want to take the 2 doses. But it also means that promotion and pushing people to take their vaccine and making sure they take the 2 doses is going to be the most important part of this in the long run. So with that, why don't we talk about some other things? How was Christmas? You guys have a good Christmas?
Yes, I didn't listen to you, and I did visit my family, but it was a small gathering. It's the first time I'd seen them in a long time. So, and I said, I'm not coming if anybody is experiencing any of these symptoms, and I gave them the list of symptoms. And I think
I only got together with my pod, which is basically my 2 kids and their significant others. We've been seeing each other throughout this entire pandemic, and I know they're extremely careful. So although you can never tell who they might come in contact with, so there is some risk there, but
Well, one of these days we should probably talk about what they call bubble management, and this has a lot to do with blockchain work, where you're looking at and actually have verifiable amounts of likelihood that each person in your bubble has or has not made contact with other people who are ill with COVID. And then you manage the blockchain as you would with the currency or any other blockchain to say, yes, I could have the disease, or no, I probably don't have the disease, and understand it's sort of like an dosimeter, if you will, that you're wearing in the cyber world. And we'll talk about that at some point.
Traditional 4-year students love Lawrence Technological University's thriving campus life, but LTU has always met non-traditional students' needs too. Lawrence Tech offers over 100 degree and certificate programs that can get adult students started or back on track. And most of our classes are conveniently offered evenings at our beautiful Southfield campus or online, so you can balance your social, family, and work life even while you power up your career. Lawrence Tech, where Blue Devils dare.